Hi guys. So today, as I promised last time, we will be doing back titrations. Yes, last week we did simple titration questions. This time we'll be doing more complicated back titrations. I will not explain in what back titration is in general. I will explain it using an example question. Yeah, I think that's the fastest way and the most efficient way. So let's just dive into it and then I'll show you where this back titration thing is happening in the question. Okay, so when 75 centimeters of 0.5 molar hydrochloric acid were added to 125 grams of impure magnesium carbonate, some acid was left unreacted. This unreacted acid required 21.6 centimeter cubed of 0.5 molar sodium hydroxide for complete reaction. Calculate the percentage by mass of magnesium carbonate in the impure sample. Okay, you can pause this if you're watching. I mean, you will be watching it as a recording because I still don't let anyone on my streams live. Okay, so you can pause, read it again, but I'll continue. Right, so what's happening? These questions, it's better to draw the scheme. Yeah, my drawing skills are like approximately what my kids have when they were like 5. But still, if you draw the diagram, I think it might help you to just structure what's happening in this question. So let's see what happened. So they've added 75 cubic centimeters of 0.5 molar HCl to 125 of impure magnesium carbonate. Okay, so we had an impure magnesium carbonate, solid, yeah, so that's MgCO3 and some impurities. And what do we know? We know the mass, yeah, of the whole thing. It was 125, so that's like the mass of the mixture. It's 1.25 grams, yeah, so it has magnesium carbonate and impurities. Then they transferred this to HCl. And we know everything about this HCl. So we know that the volume, maybe I need a, okay, we know the volume was 75 centimeters cubed. And we know the concentration of HCl was 0.5 mole per cubic decimeter. Right. Once they've done that, what happened? Well, obviously MgCO3 and HCl reacted. Whenever you have impurities, if nothing special is written, we say that impurities do not react with the acid. Okay, so if you are reacting an ore or like a mixture of your like main substance that has some impurities, then we decide that only main substance would react with HCl, unless there are hints that that's not the case and there are some special impurities that react, but not here, not in IB. And in A level, sometimes they could give you tricky questions, but it would be explicitly said in the questions that impurities are also reactive. Okay, so the reaction will happen, yeah, when we do that. So MgCO3 would react with HCl to form MgCl2, CO2, and H2O. And then when you balance, it's 2 in front of HCl. So MgCO3 and HCl react in 1:2 ratio. Don't ask me why. If you don't know this reaction, you have to go back to GCSE stuff. It was there, or MYP, yeah, so it was in GCSE or MYP. Right, so we've mixed that. Then let's see what's happening next. Next, so they reacted, right? And when they reacted, what did we get? Well, we got magnesium chloride, right? So this was a solution of magnesium chloride, CO2, and water. And what else? Impurities did not react. And also this is where the back titration is important. Yeah, so the unreacted acid required some sodium hydroxide. So you see here, we know that the acid was added in excess, right? So we have some unreacted acid. So like we have MgCl2 solution aqueous, and here obviously it would not be as a separate layer, but just to show you. So this is unreacted acid, right? And this is where we start the back titration, right? So you see what they did. So they've taken some substance which was like in the mixture or impure, for which and then you had to find the moles or like concentration or percentage by mass. So you need to find MgCO3, yeah, so something about MgCO3 in the mixture, and you cannot titrate it directly for some reason. And that's then what you can do is you can react it with excess of acid or with excess of some other substance, and then titrate that unreacted amount with an AOH to find how much was left over. You see where it's going, right? So you see, we know exactly how much acid we've added. We know that some acid was left unreacted. And now with titration, we can find how much acid was left unreacted. So it's not direct titration on MgCO3, but it's back titration. Yes, it's indirect. So back titration on the unreacted acid. Okay, well, right. Let's read it again. So unreacted acid required that amount of sodium hydroxide to complete reaction. So now they basically what they did, they titrated. Yeah, so they added NaOH from the burette. Magnesium chloride does not react with NaOH. Yeah, so they titrated well, we assume that it doesn't react. And NaOH only reacts with the acid. So this is the titration. And we know everything about NaOH. So we know its volume, which is 21.6 centimeters, and we know its concentration, which is 0.5 mole per cubic decimeter. And the titration reaction would be HCl that was left under, oh, okay, you cannot see it. So just move up. So the titration reaction would be HCl that was left over, yeah, so unreacted acid, with an NaOH that you're adding from the burette, gives you NaCl and H2O. Okay, so just one more time. Yeah, so one more time. So what do we know? We know how much acid we added to MgCO3, and from the titration, we would find how much acid was left unreacted after this initial reaction, yeah, after the reaction of HCl with MgCO3. Then if you subtract initial moles, so minus what's left unreacted, you would find the amount of moles of HCl that reacted with MgCO3, and you know in which ratio they reacted, so you would be able to find the moles of MgCO3 in that mixture, in the initial mixture. Okay, let's do it. So this is just the same question repeated, yeah. Right, so first, what can we do? So first, we need to find, we always start from the end, yeah? So titration questions also, last time we always started from the end. So what can we do? We can find the moles of sodium hydroxide. Yeah, or we can start from here. We can find the moles of HCl initial, doesn't matter. I will start from the end. So I would start by finding number of moles of NaOH that was used in titration. It's concentration times volume, so it's 0.5. 100 times 21.6 in cubic decimeters, so 0.0216. Yes, to convert from centimeters to decimeters, remember to divide centimeters cubed by 1,000. 0.216, so that is 0.0108 moles. That's number of moles of NaOH. Now what do we know? Now we know, remember that in the titration, HCl and NaOH react with in 1-to-1 ratio, which means that the amount of moles of HCl that reacted with NaOH was the same as NaOH. Right, so second step, we know that moles of HCl, and what is this HCl? It's the HCl that was left over here, yeah, so that was left over after it's reacted with magnesium carbonate. I will denote it as HCl left over. It's also 0.0108 108 moles. So that's what's left after the reaction. I will maybe write it down. So it's left after reaction with MgCO3. Right, what's next? Next, we can find the number of moles like, what do we need to know? We need the initial moles of HCl, right? So that's what I will find. So moles of HCl that was added initially to our MgCO3. Also C times V, so 0.5 times 75 over 1,000. 0.5 times 0.075, which is 0.0375 moles. And then so I know that this is the amount of moles that we've added to magnesium carbonate. This is the amount of moles that was left after the reaction. And if I subtract, I would find the amount of moles of HCl that reacted. Reacted with magnesium carbonate. Yes, so that would be initial amount minus what was left, so minus 0.0108. 0.0267. So that's the moles that reacted with magnesium carbonate. MgCO3, so it's these moles, right? So 0, what was it? 267. 267. Yes, 67. So that's these moles. So now you know that this amount of acid was required to react completely with magnesium carbonate in that initial impure sample. And well, and that's essentially it. Yeah. So now using the moles, you can find, I mean, using the molar ratio, you can find the moles of MgCO3. So MgCO3 reacted in 1:2 ratio with HCl. So we find moles of MgCO3. 1:2 ratio means that it's twice less than moles of HCl. 0.267 over 2. Which is 0.01335. And I'm running out of space. Okay, let's see if I can add a page. You know what, I'll duplicate it so that I see the question. That's the same. Yeah, okay, and then I'll just remove. Yes, and then so we found the amount of moles of MgCO3, and then I can find the mass of MgCO3, because what do we need? We need percentage by mass of magnesium carbonate. So it's the mass of pure Mg carbonate divided by the total mass by 125. So what step is that? Step 6. Well, usually these are, in IB, it's like a 4-mark question. In A-level could be up to 6 marks. But for A-level, I think it would be slightly more complicated. I will show you the next question if we have time. Let's see. Right, so finding mass of MgCO3. So we know the moles and we know MR from the periodic table. So moles would be 0.01335. 335. Molar mass. Okay, so magnesium 24.3, carbonate 12, and oxygen 16 times 3. 84.3. Remember, if you're doing IB, remember to put all the relative atomic masses to 2 decimal places, how they're in the periodic table. For A-level, I think it's to 1 decimal place, depending on the board, but just use the values from your periodic table. Don't round anything. Times 0.01335. That is 1.125 grams. Well, it should be to 3 significant figures, because this should also be to 3, but again, it's not about significant figures now. Right, 1.125 grams, and then percentage by mass. And of course, intermediate steps, you don't have to round correct. I mean, you have to round correctly, but not to the correct number of significant figures. You always keep a little more, except for IB. I need to make a lesson on significant figures, because I keep referring and keep saying I'll explain later. Right, so okay, so we know then it's mass of magnesium carbonate divided by the mass of the mixture. So it's 1 point and times 100%, right? Because we need percentage. So it's 1.125. That's pure magnesium carbonate impurities. We said impurities we assumed did not react with HCl. Well, and MgCl2 did not react. Right. And then, not with HCl, with NaOH, I mean, with NaOH. And then we divide by 125 times 100. 125 over 125. So that is 90%. Well, that's the back titration. So I hope you got where the back titration is coming from. So back titration is titrating the leftover of the acid in this case. And then they can ask you all sorts of different questions about it as well. So like, for example, what assumptions did we make? Well, the first assumption that we made is, for example, that impurities do not react with HCl. Then what else? Like, if you were doing this in the lab, you would need to boil this solution actually, right? To get rid of the CO2, because CO2 reacts very nicely with an NaOH, so you would have gotten like a higher titer than it really should be. So all kinds of experimental questions they can also ask relative, well, in these sorts of calculations. Okay, right, one more question. I hope we can do it before my next lesson. Let's see, so the lead ore consists of lead carbonate and impurities. 2 grams of crushed ore was added to 25 cubic centimeters of 1 molar nitric acid in a beaker. When no more reaction was observed, the mixture was filtered into 250 cubic centimeters volumetric flask and made up to the mark with distilled water. Then 25 cubic centimeter portions of this solution were titrated with 0.1 molar sodium hydroxide. The average titer was 12.70. Calculate the percentage by mass of lead carbonate. Right, I'll quickly draw it out. Okay, hold on a second. Yes, okay, so I will draw it out. So we have 2 grams of crushed ore. Well, crushed means powder, but doesn't really matter. Okay, so we have 2 grams. It's again, that's the mixture, right? The ore is a mixture. 2 grams. It has lead carbonate, which is PbCO3, and impurities. Okay, maybe I need a little more space. Can you even see what I'm writing? Yes. Okay, and then we add this to a beaker with nitric acid. So we add HNO3, and we know the volume of HNO3 and the concentration. Then they react, the reaction happens, and so you have some solution. Yeah, let's say, so you get like products of the reaction and some unreacted HNO3. How do I know that? Well, because later it's titrated with sodium hydroxide, right? So what else could it be? So it's unreacted HNO3. Unreacted. This volume is still 25, right? Then, so I'm here now. So we've added, the reaction happened. When no more reaction was observed, the mixture was filtered into a 250 cubic centimeters volumetric flask and made up to the mark with distilled water. So now they get rid of, like, why do they do filtration? Well, they get rid of impurities, right, that didn't dissolve, that didn't react with HNO3. Because we assumed that only lead carbonate reacted. Okay, so now they take this, and now we know that all of that unreacted HNO3 has the volume of 250. So basically what they do is they filter it out and dilute this solution up to, well, 10 times to 250. So this is the solution that has unreacted acid. Unreacted acid. Okay, fine. Up to this point, I hope it's clear. I'm used to asking questions, so just my professional habit during the lesson, but obviously I cannot ask you. So, okay, just one more time. Crushed ore reacted with HNO3 of that volume and that concentration, so we know exactly how much we've added. Then some HNO3 was left unreacted. Then they filter the solution, then dilute so that the unreacted acid is now in 250 cubic centimeters volume. And then what do? Then they don't titrate the whole thing. They could titrate the whole thing. That's fine. Yes, so they could have done it like in the previous question. But this time, they don't titrate the whole 250 cubic centimeters, but they take a tiny portion. They take 1/10, 25 cubic centimeters, and titrate that. Okay? So I still ran out of space, but let's see, I will try to fit it in. So then they take a little bit of this. Yeah, I can put it here. So now they take 25 cubic centimeters of the unreacted acid. Yeah, again, that's unreacted HNO3, and titrate this with NaOH. So this is your back titration. And we know everything about NaOH. So we know its concentration and we know its average titer. Yes, so the only difference with the previous question is that they don't titrate the whole thing. So if they titrated this flask, then that, or even this, yeah, or even this, that's fine. That would have been the same as the previous question here. The only difference is that, well, they titrate a tiny portion. Right, so let's start solving. So I will start solving from here. Yeah, so first I would find how much, oh, actually, no, first let's write down the reactions. Let's down the reaction. So this reaction of lead carbonate with HNO3, the first reaction, it is PbCO3 and HNO3 gives you lead nitrate, CO2 and H2O. Yeah, that's the reaction of like the initial reaction. It is balanced, yes. And then the second reaction is titration. In titration, we're reacting NaOH with HNO3. So that's like leftover HNO3 reacting with NaOH from the burette. So we get NaNO3 and H2O. Okay, I'm just checking that you see everything. Yes, fine. Next, so let's now start solving. So I will start solving from this side. Yeah, so from the end. So what do I know? I know the amount, I can find the amount of moles of NaOH that was needed to neutralize all the unreacted acid that was taken from this sample. Yeah, so all the unreacted acid in 1/10 of the volume of the initial acid. Let's do it. So first, C times V. How long is this stream already? 22 minutes. Okay. Right. NaOH. Maybe I highlight a little bit so that you are not lost. Hope you're not lost. I mean, I'm not used to working without feedback, but I'll manage. Okay. So 25 cubic centimeter portion of solution were titrated with 0.1 of sodium hydroxide. The average titer. Right, so concentration is 0.1. Average titer is 12. Titer, what is titer, by the way? Titer is whatever you're dropping from the burette, right? So that's the volume of NaOH that was needed. Well, 12.70 over 8,000, which is 0.0017. I hope by now you remember that it has to be in decimeters cubed. 0.001270 moles. Then, so that's the moles of NaOH that was used in the back titration, yeah, in the titration. Then I know that NaOH and HNO3 reacted in 1:1 ratio. So from here I find the moles of unreacted acid. Unreacted meaning unreacted with lead carbonate, yeah? So I would say leftover again. It's 1:1 ratio with NaOH, so same. And what is that? So I will let's write it down. So this is moles of HNO3 left after reaction with PbCO3 in 1/10 1/10 of the initial volume, yeah? Well, it's like 1/10 of the initial, I will just write 1/10. 1/10 of moles. Why is it 1/10 of moles? Because you see, what did they titrate? This volume was 250. So this volume 250, it contains all the molecules of unreacted acid. Yeah, so everything that was left after the reaction with lead carbonate is here. But then they titrate this 1/10. Yeah, 25, it's 1/10 of 250. So they take 1/10 of those moles and titrate them. So it means that this, what we got, it's 1/10 of the HNO3 moles left after the reaction. I hope that's fine. Because next step that we'd have to do is we will find the moles. Oh, this I will write. Okay, I'll write it here. So this, it's in 25 cubic centimeters. Now I have to find the amount of moles here. Yeah, so what we found, it's moles of the acid in this flask. Now I'm going back. So if in 25 cubic centimeters I have like 0.00127 moles, then here I would have to multiply it by 10, because this volume, it's 10 times larger than 25. So it means that it would have 10 times more molecules. The concentration would be the same, so careful, yeah, but moles would be bigger. So moles of HNO3 left over a total. A total meaning in 250. So it's just 0.001270 times, well, why is it 10? I would just write it that it's 250 over 25, because it doesn't have to be 10 times. In this question, it's 10 times, but then it could be something else. Yeah, so you just divide the initial volume over the titrated volume. Well, in this case, it's 10, and I don't need the calculator for that. My math is good enough for this. Okay, so 0.0127, it's fine, right? Yeah, 0.0127. So this is how much acid was left after the reaction. Well, and then everything else, it's similar to what we did last time. So then I would find, let's see what I find. I find the initial number of moles of acid. So I know that initially I've added 25 of 1 molar nitric acid. So again, I do C times V. It's 1 times 0.025. Yeah. 0.25 moles. And now I can finally find how much acid reacted. Yes, so now moles of okay, HNO3 reacted with lead carbonate. So that's initial amount, which is 0.025 minus what's left. Yeah, so minus this. Yeah, 1, 2, 7. The 0 is not necessary, actually. I don't know why I keep writing it. Yes, that's okay. This 0 is not necessary because it's 3 significant times 4 significant, so it should be 3 significant, but I'm not correcting. 0, 0, 1, 2, 3 moles. That is the amount of acid reacted with lead carbonate. So essentially, it's this moles. Yeah, so this is 0, 0, 1, 2, 3. That's how much reacted. And then from here, we know that lead carbonate reacted with HNO3 in 1:2 ratio. So now we can find moles of lead carbonate. Now what step is that? That's like step 106. Moles, is it really 6? Yeah, it is. Okay, so now moles of lead carbonate. That is, okay, so we said it's 1:2 ratio, so 0.00123 over 2. over 2, it's 6.15 times 10 to the negative 3. And next, what do we need? What do they ask? They ask for percentage by mass again. Okay, now we find mass of lead carbonate, which is moles times mR times molar mass. So 615 times 10 to the minus 3 times, okay, lead. Let me see. I'm not opening the periodic table because these questions are quite advanced, yeah? So if you don't know how to find the mass, probably you shouldn't have watched this whole video. Maybe I should have said it in the beginning, but I'm not explaining like easy things, yeah? So if you find, for example, that you don't know how to find the mass of lead carbonate, then it's definitely not the time to solve back titration things, right? You have to first go back and learn how to do simple stoichiometry questions. Okay, so lead is 207.2 plus carbon is 12, oxygen is 16 times 3, so 267.2. But again, for IB, you remember to put your ARs to two decimal places. Right, that's fine. And then that's times 6.15 times 10 to the minus 3. That is 1.64. 1.64 grams. And then percentage by mass. So it's mass of lead carbonate divided by the mass of the ore. Yes, and of course here, especially with percentage by mass, you have to do the sanity check, right? I call it sanity check. So of course your percentage by mass cannot be like above 100%. And if you get some small number like 0.01% or something like that, then something is wrong. Yeah, so it should be if like a normal number. What's ore? Well, most of it must be lead carbonate. Yeah, so at least like above 20, maybe above even 50%. Could be below 50, but not 0.1, okay? So 164 over 2, that looks good. Yeah, so that looks good. A decent amount over 2, it is 82%. That's the answer. Right, perfect timing. How long did it take? 32 minutes. Okay, consistency is good. All my streams are now like about 30 minutes. Right, so I let you I let you go. Yes, I let you go, but you're not in my lesson in real time. So I'll just see you next time. Take care.